Okay, so when we start learning chemistry uh, in any class, we always learn the mole concept first. So, mole concept is the basic, or you can say the fundamental topic in chemistry subject. So, when we start mole concept, we learn two key terms first, the atomic mass and the molecular mass. If you go in deep, we learn relative atomic mass and relative molecular mass. So let's start with relative atomic mass. Now, relative atomic mass is the weighted average of the atomic mass of all the isotopes of an atom or of an element relative to 1 by 12th mass of one carbon 12 atom. Okay, because each element has not, I mean, like most of the elements have isotopes. Therefore, we do the average. So, the weighted average of the atomic mass of all the isotopes of an element relative to 1 by 12th mass of one carbon 12 atom is called relative atomic mass. Now, if you'll say atomic mass will have a unit. If you'll say atomic mass, then it will have a unit. If you'll say relative atomic mass, it won't have any unit. It's relative. So we don't put units there. Now, relative molecular mass has two definitions. One is theoretical definition and the another one is the working definition. So let's start with the theoretical definition. Theoretical definition is it is the weighted average of the molecular mass of a molecule relative to 1 by 12th mass of one carbon 12 atom. That's the definition of relative molecular mass. Same like relative atomic mass. Once you learn the relative atomic mass definition, you just change from atomic mass to molecular mass, and then of all the isotopes, you write average of the molecular mass of a molecule, and then rest will remain same. Now this is the theoretical definition. Now what is the working definition? Working definition is, like, let me show you what is the working definition. So working definition is it is the sum of the atomic mass, relative atomic mass of all the atoms present in the molecule. That's the working definition. So let's understand this with the help of an example like sulfuric acid. So the relative molecular mass of sulfuric acid. So how do we calculate relative molecular mass of sulfuric acid? To calculate it, first thing we do is to identify the types of element present in sulfuric acid formula. So in H2SO4, there are three elements: hydrogen, sulfur, and oxygen. So we use the working definition and then we add the relative atomic mass of hydrogen, relative atomic mass of sulfur, and relative atomic mass of oxygen. Now, when you do the relative atomic mass of oxygen and when you finish it, okay, then we need to look at the formula again, and then we need to look at the subscript of these element, and that subscript will tell us the number of atoms of each element present in the molecule. For example, there are two hydrogen atoms, one sulfur atom, and four oxygen atoms. After putting these subscript in front of the atomic uh, relative atomic mass, you need to multiply it and then add them together. So 2 times 1 plus 32 for sulfur and 4 times 16 for oxygen, and then you're going to add them together and then it will come like 98. So 98 is the relative molecular mass of sulfuric acid. If you'll say only molecular mass, then it will have a unit. So the molecular mass of sulfuric acid is 98 gram per mole, whereas relative molecular mass is unitless. So relative molecular mass of sulfuric acid will be 98, whereas molecular mass of sulfuric acid will be 98 gram per mole. Okay, so that's how we calculate the relative molecular mass or the molecular mass of sulfuric acid. So from here it is clear that relative molecular mass has two definitions. One is theoretical definition, another one is working definition. Okay, when it comes to write the definition, we write the theoretical definition in examples, but when it comes to calculate the relative molecular mass or molecular mass, then we use the working definitions. The meaning of these two definitions is same. Why do we do the average of the molecular mass of a molecule? Because each molecule has isotopes. For example, CO2. So in CO2 there are two elements, carbon and oxygen. Carbon has three isotopes, carbon 12, 13 and 14. Similarly, oxygen also has three isotopes, 16, 17 and 18. So when you calculate the molecular mass of CO2 using different types of isotopes, you'll get slightly different molecular mass. To calculate the molecular mass of CO2, then you need to do the weighted average, right? So first you apply the definition, sum of the relative atomic mass of all the atoms present in the molecule, to calculate the relative molecular mass of CO2. And that will be using different types of isotopes. So you first apply the working definition to get the relative molecular mass of CO2, okay, and which will be different if you use different types of isotopes. Now once you use different types of isotopes, you'll get different molecular mass, and then you do the weighted average to calculate the relative molecular mass. There comes the theoretical definition. So both definitions are helpful, and I don't say easy to remember or easy to learn, but you need to learn it because this comes in the exam as I have shown you here. Thanks.